Today, we are looking at Elon Musk's companies as one connected system.
Not as separate brands, but as parts of a larger industrial machine.
The central question is simple. How could that machine support space settlement?
And more specifically, how could it support a long-term human presence on Mars?
Let's start with the obvious piece, SpaceX.
SpaceX is the transport layer. It builds rockets, spacecraft, engines, and launch operations.
Its reusable rocket strategy matters because Mars requires repeated, heavy, affordable transport.
A Mars settlement cannot depend on one heroic mission every decade.
It needs cargo flights, crew flights, refueling, repairs, and constant replacement parts.
Starship, if it succeeds as intended, is the core vehicle for that vision.
It is designed for large payloads, reusability, and missions beyond Earth orbit.
That makes it the spine of any serious Mars colonization plan.
But rockets alone do not make a civilization.
Exactly. A Mars outpost needs energy, mobility, communications, construction, computing, and governance.
That is where the other companies start to connect.
Tesla becomes more than a car company in this framework.
Tesla is an energy, battery, robotics, software, and manufacturing company.
On Mars, electric vehicles would be more practical than gasoline vehicles.
There is no oil refinery, no gas station, and no easy combustion supply chain.
Electric rovers, cargo haulers, mining vehicles, and construction machines would make more sense.
Tesla battery expertise could support local storage for solar and nuclear power.
Mars has weaker sunlight than Earth, but solar energy is still useful.
Energy storage is critical because storms, night cycles, and peak demand create instability.
A settlement needs batteries, power electronics, grid software, and redundant systems.
Tesla's work in large-scale battery packs could translate into settlement-scale energy management.
Its manufacturing style also matters. High volume, automated, tightly integrated production.
For Mars, the dream is not shipping every object forever from Earth.
The dream is building more locally, with machines that can produce machines.
That is where manufacturing becomes almost as important as launch.
A Mars colony would need standardized parts, modular vehicles, and repairable systems.
Tesla's factory lessons could influence how habitats, vehicles, and power systems are produced.
Then there is solar energy, historically tied to Solar City, and now Tesla energy.
Solar panels, battery storage, and grid control become part of the survival stack.
On Earth, they support homes, utilities, and businesses.
On Mars, they become life support infrastructure.
Because power is oxygen, heat, water processing, food production, and communication.
No power means no colony.
So Tesla energy fits naturally into the Mars system.
Now consider Starlink.
Starlink is the communications layer around Earth, using large satellite networks.
For Mars, a similar idea could provide orbital internet and navigation support.
A Mars settlement needs communications between habitats, vehicles, satellites, and Earth.
There is always a delay between Earth and Mars, sometimes many minutes.
So Mars needs local networks that function independently.
A Mars version of satellite internet could connect rovers, bases, drones, and science stations.
It could also help with mapping, weather monitoring, landing guidance, and emergency response.
In colonization, information flow is not a luxury.
It is how people survive, coordinate, and build trust.
Starlink also gives SpaceX practical experience operating vast satellite constellations.
That experience could matter when building communications infrastructure around another planet.
Next, the Boring Company.
At first glance, tunnels may seem unrelated to Mars.
But on Mars, underground space could be extremely valuable.
Mars has radiation, temperature swings, dust, and a thin atmosphere.
Surface habitats need protection, shielding, and pressure containment.
Tunnels or buried structures could help protect humans from radiation and micrometeorites.
The Boring Company's tunneling concepts could support underground habitats, transport corridors, and storage.
Even if current Earth tunneling methods require adaptation, the strategic idea is clear.
A Mars settlement may eventually need to go underground.
Subsurface construction could create safer living areas, laboratories, farms, and emergency shelters.
Tunnels could also connect habitats without requiring people to suit up outside.
That improves safety, productivity, and daily life.
Now let's bring in XAI.
Artificial intelligence could be the decision support layer.
Mars will be too far away for constant real-time control from Earth.
Crews will need autonomous systems that can diagnose problems quickly.
AI could help monitor power grids, life support, farming systems, and vehicle fleets.
It could also assist science teams, engineers, doctors, and mission planners.
In a dangerous environment, early warning is everything.
AI could detect equipment patterns that humans might miss.
It could recommend repairs, conserve power, or reroute vehicles during emergencies.
It could also manage inventories, construction schedules, and habitat expansion.
If used responsibly, AI becomes a survival multiplier.
But it must be reliable, transparent, and designed with human oversight.
Then, there is Neuralink.
Neuralink is not a Mars colonization company directly.
Its public focus has involved brain-computer interface technology and medical applications.
In a long-term space context, the speculative connection is human-machine interaction.
We should be cautious here, because many possibilities remain unproven.
Still, advanced interfaces could eventually help people control tools, robots, or assistive systems.
On Mars, medical care is constrained, and specialized support is limited.
Technologies that restore function or support disabled users could be very valuable.
The broader idea is tighter communication between humans and machines.
But again, that remains a cautious future-facing connection.
Now consider X, formerly Twitter.
A social platform seems far removed from rockets and batteries.
But information networks shape culture, coordination, funding, and public support.
Mars colonization would require massive storytelling and public legitimacy.
People must understand why it matters, what it costs, and what risks exist.
A public communication platform can build attention, recruit talent, and influence debate.
It can also spread misinformation, conflict, and unrealistic expectations.
So the communication layer is powerful, but it must be handled carefully.
A settlement is not just engineering.
It is a society with narratives, rules, values, and public trust.
If we see these companies as one tool, the structure becomes clearer.
SpaceX moves mass between worlds.
Tesla powers, stores, moves, and manufactures.
Starlink connects people, machines, satellites, and bases.
The Boring Company helps create protected infrastructure.
XI supports autonomy, planning, diagnostics, and scientific analysis.
Neuralink points toward future human-machine interfaces and medical support.
X helps shape public conversation, recruitment, and cultural momentum.
Together, they resemble a civilizational toolkit.
Not a complete civilization, but a foundation for one.
The missing pieces are also important.
Mars colonization needs food systems, medicine, law, psychology, education, and governance.
It needs water extraction, radiation shielding, recycling, and local materials processing.
It needs democratic legitimacy, safety standards, and international cooperation.
No single entrepreneur or company can solve all of that alone.
But a unified industrial network could accelerate the physical infrastructure.
Now, what else can these companies be used for in unison?
The first answer is disaster response on Earth.
Imagine wildfires, hurricanes, earthquakes, or war-damaged regions.
Starlink can restore communications when ground networks fail.
Tesla batteries can provide emergency power for clinics, shelters, and command centers.
Electric vehicles can move supplies where fuel logistics are disrupted.
SpaceX could potentially launch emergency satellites or deliver rapid orbital services.
AI could coordinate relief, map damage, and forecast resource needs.
That same integrated model could support remote communities.
Places without reliable grids, roads, or internet could benefit from combined systems.
Solar power, batteries, satellite internet, and autonomous tools could transform access.
Education, telemedicine, commerce, and emergency services could improve dramatically.
Another use is national infrastructure resilience.
Modern societies are vulnerable to grid failure, cyber disruption, and supply shocks.
Distributed batteries, local energy generation, and resilient communications reduce fragility.
AI can help detect faults and manage complex networks.
Tunneling could support transportation, utility corridors, and protected infrastructure.
In that sense, the Mars Toolkit can also harden Earth.
The same logic applies to military and security operations.
Communications, mobility, power, logistics, and autonomous analysis are all strategic assets.
But that raises ethical and legal questions.
Dual-use technology can protect people, but it can also intensify conflict.
So responsible oversight matters.
Another combined use is building sustainable cities.
Electric transport, renewable storage, AI planning, and underground infrastructure could reshape urban life.
A city that wastes less energy and communicates better is more adaptable.
Tunnels could reduce surface congestion in some contexts.
Batteries could stabilize the grid during peak demand.
Satellite internet could support underserved areas around those cities.
AI could optimize traffic, energy, maintenance, and emergency response.
Another possibility is ocean, Arctic, and desert development.
Extreme environments on Earth are training grounds for space settlement.
Remote bases need power, communications, transport, shelter, and autonomy.
Those requirements resemble the early needs of a Mars outpost.
If the system works in Antarctica or the desert, it teaches useful lessons.
It also produces immediate Earth benefits.
So the broader theme is this: Mars pushes integration.
You cannot solve Mars with isolated gadgets.
You need a system where launch, power, transport, communication, construction, and intelligence connect.
That is why looking at these companies together changes the picture.
Individually, each company serves a market.
Together, they suggest an architecture for surviving and expanding in extreme environments.
The risks are serious, though.
Over-centralization can create dependency on one corporate ecosystem.
Space settlement also involves public interest, not just private ambition.
There must be transparent safety practices, international norms, and human rights protections.
A Mars colony cannot simply be a company town with oxygen.
It would need accountable institutions and a culture of shared responsibility.
There are technical risks, too.
Mars is cold, dry, irradiated, distant, and unforgiving.
Reusable rockets still require huge reliability at scale.
Life support must operate for years, not demonstrations.
Local production of fuel, water, food, and materials must be proven.
Human psychology in isolation must be treated as mission critical.
So the unified tool idea is powerful, but not magic.
It is a plausible framework, not a finished answer.
If successful, the same toolkit could produce a major shift on Earth.
Cleaner power, better communications, stronger disaster response, and smarter infrastructure.
If misused, it could deepen inequality, surveillance, dependency, or militarization.
That is why the conversation must include engineers, citizens, governments, and communities.
Mars colonization is often framed as escape.
But the better framing may be capability.
Can humanity learn to build closed-loop, resilient, sustainable systems?
Can we survive in places where waste, delay, and fragility are deadly?
If yes, those lessons may help Earth first.
That may be the most practical value of the Mars vision.
It forces us to think in systems.
Not just cars, rockets, satellites, tunnels, or artificial intelligence.
But transportation, energy, Information, shelter, medicine, and culture working together.
That is the real integrated tool.
And now, a word from the New Sentinel.
The New Sentinel is a podcast built for curious, serious, and adventurous listeners.
Every episode delivers deep dives across a wide range of subjects.
From pop culture's glitz and glamour to the complexity of military operations.
The New Sentinel brings thoughtful discussion, detailed analysis, and engaging storytelling.
You will hear expert interviews, clear context, and conversations designed to inform.
Whether you love entertainment, global security, strategy, technology, or culture, there is something here.
Tune in, view, subscribe, and comment to stay informed and entertained.
And if you are an entrepreneur, the New Sentinel can help advertise your product or service.
Reach audiences who value insight, substance, and fresh perspectives.
The New Sentinel is where serious curiosity meets compelling conversation.
Subscribe today and join the conversation.
To close, the Musk ecosystem is best understood as a stack.
A stack for movement, power, data, automation, communication, and infrastructure.
Mars colonization would need exactly those layers, plus many others.
The companies do not guarantee a Mars city.
But they do map onto many of the hardest early requirements.
Launch gets people and cargo there.
Energy keeps them alive.
Connectivity keeps them coordinated.
Automation helps them operate at distance.
Tunnels and protected structures help them endure the environment.
Manufacturing helps them move from survival to growth.
And